Hi, I'm Ossi Mokren from the University of Haifa and I will present LPA. Let me start by asking you about your choice of words. Do you get to watch a film or a movie? And can we detect that? If we do, will it help us in finding whether indeed Shakespeare was not the author of A Lover's Complaint, as some suspected? Given a domain, let's say movies, we claim that we can identify personal style in the domain by identifying how an individual is different from the domain in their choice of words. That is, we claim that in a topical domain, personal style are the elements that differ most in usage frequency between an individual and the domain. It is well known that both personal vocabularies and the distribution of words in a domain are distributed, long tail, in what is often termed a zip distribution. If we look at a ranked list of terms in each vocabulary, it can be divided to the top very popular words and a long list of infrequent words. If we consider that a domain's ranked vocabulary is the result of the aggregation of all personal word frequencies, we can say that the domain is divided to domain popular terms and a very long tail of infrequent terms. If we borrow from Debussy's music is the silence between the notes, we could say that style is the silence between the words. And less poetically, the personal style can also be measured by domain popular words that are missing or underused in a person's vocabulary. Let us follow a toy example here to understand, taken from the movie domain. Here is a ranked personal usage. For example, in this toy example, the word favorite is very popular with this user. In the domain, here, which is the collection, and a more accurate snapshot, the word film has a global probability of 2%, 2.1, and a movie of 1.8. We would like to find the terms that most distinguish users from the domain, as depicted to the right. On the lower panel, we see a user that uses the words Bond, Pokemon, villain, much more than their relative domain frequencies, but hardly mentions horror, comedy, or love. So how do we obtain these differences? We would like to find the per element, per word distance between each person and the domain. We evaluated 4 different distance metrics using a set of criteria, and the details can be found in the paper. The idea behind that is to assign, The idea behind that is that the elements that contributed most to the distance between an individual and domain constitute the individual's personal style. We chose as a metric, according to our criteria set, the mutual entropy measure of KLD with a backup addition suggested by BG in 2003. The chosen distance metric increases distance for missing popular terms and overused domain rare terms, while decreasing the effect of the distance for the vast tail of infrequent missing words. And let us see what LPA does. LPA creates for each person or entity in domain 2 features. The first is its LPA distance, which is the entity's KLD distance from the domain. And the second is the LPA signature. These are the top N words that contributed most to its LPA, to the entity's LPA distance, their relative importance, which is the KLD distance measure between local frequency and global frequency, and the corresponding sign, which is either a plus for overused words or minus for underused or missing terms. We have validated the LPA, and again the details can be found in the paper, but the idea was we would like to show that a person's or entity distance is not merely an artifact of the entity being a sample, the vocabulary of a user being a sample from the domain. And we also show that LPA signature is a pair entity dimension reduction representation, and that LPA is a fast method. And let us show you some of the applications and what can we do with LPA. So first we look at using LPA for impersonation detection in social media. For that, and we crawled a dataset from IMDb of 4,000 users. Each authored at least 30 reviews from over 18 years. And the first type of impersonation we find is authors that maintain multiple accounts, sometimes also referred to as sockpuppets. We compared the LPA signatures of all IMDb users and found a subset of pairs of signatures that were similar. We were able to validate in several cases that the accounts are indeed authored by the same person, as in these examples here and here. But what would be the precise definition of similar? So to that end, we performed an experiment in which we halved a small subset of chosen accounts and then made the comparisons, knowing the ground truth. We also compared LPA's performance to a TF-IDF with cosine similarity exploration baseline. In both cases, we found that the average distance between, in both cases, we found the average distance between all distances, the distance matrix between all accounts. And then we found pairs that are closer than, let's say, 1 standard deviation, then the average 2 standard deviation, and the average 3 or 4. And you can say that while LPA outperforms, an amazing result is obtained with finding average, in this case, distance of average minus 3 standard deviations between accounts would find authors that are the same, accounts that have the same author. So a second type of impersonation that we found is something that we defined, and we termed it front user accounts. And these are accounts that are operated by several people to increase exposure or whatever, and impersonate as a one-person account. The hypothesis is given that a domain is a superposition of all individuals. Front user account distribution would also resemble the domain's one because it's also a superposition of several people. And we were able to validate that in an experiment with ground truth information. The details are in the paper, and we found indeed some few hundreds accounts that we suspected as front user accounts, and we were able to validate that, showing that the rate in which the rate of their contribution was much higher than the average rate for standard user accounts. Okay, so let's see other applications. Here we use again the KLD distance, but in a different way. We create a domain with all the Shakespeare books and computed distance for each of his books. Here we assume that books authored by Shakespeare will have a small distance to their own domain. Surprisingly, we see that the Lover's Complaint has a distinctive large distance and is therefore quite different. So maybe we suppose that we suggest that it might not be written by Shakespeare. And we go to another domain. Every domain that has a long-tail distribution of elements, here are music listening habits of countries as gathered from Spotify in 2017, we can also create LPA distances and signatures. So for each country, we created its own LPA signature of music listening habits. The domain is the entire listening corpus of Spotify in that year, and we computed the distances between all of the countries' signatures. It shows that this is the PCA of the resulted distance matrix. Some of the results are intuitive. Spanish-speaking countries like Spain, Guatemala, and Mexico are closer together in the lower right corner. Cyprus, Greece are very close to Estonia, Lithuania, Latvia and Slovakia, and another intriguing cluster in the middle left consists of Denmark, Sweden, USA, Germany, Indonesia, Malaysia, and Hong Kong. Here it is. I'm sorry. These countries are listening mainly to popular music. We also examined the immune system by looking at the B cells in the immune system in samples taken from organs in the human body. The work was done with Uli Hirschberg and Uli alone. And if we look at the person as a domain, and we see that some of the organs, like the gut organs, are very close to each other, and we see that the spleen, which is the central station for the immune system in the body, is actually very similar to the distribution in the body itself. So that was very interesting as well. Here we define a domain as 19th century novels and created a subset of the book's dataset as the domain. The subset contained 9 books authored by different authors. 3 of the books were authored by Jane Austen, 2 books by the Bronte sisters, each a book, and then some novels were that were authored by Lewis Carroll, Charles Dickens, Mark Twain, and Arthur Conan Doyle. We created DVR of all 9 books, domain of all 9 books, and their corresponding LPA signature for each novel. Here we see the similarity between the signatures, and we see that all Jane Austen's books are very similar to each other, and also similar to the Bronte sisters' books. So in summary, LPA is an exploration method for domains with a long-tail distribution of elements. It's the first to detect missing popular elements. In text, it can help in determining personal style. In politics, it might help to determine which subject a politician avoids, in interview which topic is avoided, etc., and many more others. We have an open source Python code which is available for use, and we would be happy to help, and I would like to thank Hagit Ben Shoshan, who was my student. Thank you very much.